given question 10 says the number of molecules of a certain drug in the bloodstream T hour after it has been taken is represented by equation M 2 into T must be equals to negative T cubed plus 3T squared plus 72T. We've given that T must be less than T must be less than 10 and greater than 0 there. That is what we've given there. Alright, so 10.1 says determine the number of molecules of drugs in the blood stream 3 hours after the drugs was taken. Obviously T is given in hours, so after the drugs was taken, we want the number of what of molecules. Remember this is what it's M. Here we have what the number of molecules we have given. That means this is M. This graph represents the number of molecules there. So we have that the number of molecules, we have T is equals to T cubed plus 3T squared plus 72T. All right, but we see this Tm, it's a number of molecules. If we want the number of molecules after of the bloodstream 3 hours after the one there, we should we can replace that by the M. Our time there will have what 3. If we substitute 3 there, we'll have 3 cubed plus 3. When you see T, you replace with what? With 3, because it's a time squared plus 72. We have there 3. Alright, this is what you'll have. Then the molecules, punching that on the calculator, this is directly, you'll have 72. Right, this will have what? 72 number of what? 72 number of what? Of molecules. Number of the molecules there. This is what we will have there, 72. All right, so given again 10.2, we have 10.2 says that determine the rate, check the rate at which the number of molecules of the drugs, right, in the bloodstream, it changes exactly 2 hours after the drugs was taken. The rate, what is the rate? If you are doing physics, you'll understand what is the rate. If you have the rate, it's something over time. It must be something over time. We call that rate, something divided by time. So, but now it's not just a something, it's a what? It's a rate of what? The rate at which molecules, certain number of what of molecules is this one. That means we're talking about MT over what? Time. But the rate, we want the rate, right, at which the bloodstream changes after that. So rate, because it's a mathematics, you must know that the rate, when we're talking about rate actual, that fraction will be the first derivative, will be the rate. Obviously we have MT, we have, as I've shown, that we'll have M over time. It's a rate, but now to evaluate that rate, we're supposed to differentiate, to take first derivative of it. We take the first derivative of this. Alright, we're supposed to take the first derivative there. Alright, that means this will be dt. So as you can see, we have taken the derivative there. So that is what we'll have. Anyways, so we'll take the derivative there. We'll take the derivative. We have our M. As you can see, we know that we have M there, our function. Isn't it M? Just a function. We have M is negative T cubed plus 3T squared plus 72T. All right, now we want the rate. We said the rate will be the function will take the first derivative, so this forms the function of the over time. So this will be derivative. You multiply there by the negative. If you multiply by the negative, will be negative. You multiply by the exponents, you'll have, you drop that exponent, negative 3, you subtract 1 down the exponents, you'll have 2 plus, you multiply there, obviously you'll have your 6t, you subtract 1 there, then here we have plus, since this will have 72. This is what we obtained there. This is what we have obtained so far. This is what we've obtained. But now, are we given t? We can evaluate that rate. If we're given t, we can substitute t. So if we can check, we've given that they said exactly after what, 2 hours. 2 hours, exactly after what, 2 hours. So we have given t. So we can substitute our t now. Then strictly t will be negative 3. We have our 2 there. T will be 2 squared plus 6. We have our 2 plus 72. We have that plus 72. All right, so we'll punch this directly. Punching that directly, just you'll have this there. You punch that directly, will be 72. Okay, here this is 72. I think here I've punched wrong. This must not be 72. Sorry guys, this number of molecules cannot be that. Will be 216. The number of molecules will be what, 216 molecules. Sorry about that. Molecules of drugs. The first question there is just 216. That will be number of molecules. Then this 72 will be is the one for the rate that will take place there. So we have then 10.3. So this it was 10.2. The one it was 10.1. So we have now here 10.3 says how many hours after taking the drugs will the rate at which the number of molecules of the drug in bloodstream is changing be maximum. Remember, I've said anytime when you see the weights maximum, minimum, nearest, largest, smallest, closest, that means that you take the first derivative, then you equate it to 0. You take the derivative there and then you equate it to 0. You understand? When you see those weights, maximum, minimum, just take the first derivative and equate it to 0. Those things. So, but now this you must be very careful. They were trying to trick it a little bit. As you can see here, there's something that you're supposed to do. Already, this is a rate. They said how many hours after taking the drug will the rate, not the original function, not the function of the molecule, the rate. Already we're talking about the rate at which the molecule, the number of the molecule, this is it's already given us as mt will be given already as t over dt. Already we have that there on the statement. You must note that. But now we know we have a maximum. So that means we're supposed to take the derivative of this guy, of the rate. All right, guys. Remember, we already have the rate. They said the rate of the molecules. We said the rate is this. This is a rate. This is our rate. Because we already have the rate, they said we know we're supposed to take the max. We're supposed to find out the derivative of this rate. Then we'll equate it to 0. But if it was the number of molecules, not the rate, we're supposed to take the derivative of the molecules. But now they said in the statement of the rate. So that is the rate there. So what is our rate? Already the rate, we have its formula here. That's the thing. The rate, already have the rate, whereby the rate is negative 3 squared plus 60 plus 72. This is t. Already we have this is the rate, is the one for the rate in form of rate. However, we know they said maximum, that means supposed to take the derivative of this again. So if we take the derivative of this, though, this will be second derivative now of that rate, because they said we should take is the maximum again. That means this will be second derivative. You multiply, there will be negative 6t plus this one will be what, 6. This is simply 0. So remember now, this, since it's a maximum, when you're given maximum and minimum, at the maximum gradient there, or whether when you take the derivative, you must equate to 0, still applying that law there. All right, so we'll equate this to what, to 0, because this is in form of the rate. Then we'll have this to be 0. You have negative 60 plus 6. Then I can take 6 like this. This side will be positive, or left with that. Then I divide by 6 both sides. This will be 1. So we have 1. And then remember, they say time in hour. This will be what? 1 hour. We'll have this. That is our time that we'll have. Because this is happening. Why we have taken this is because this is happening. This is happening, or this happens when dm over dt is maximum. As you can see there, it's maximum, because that was what it is already at the maximum position. So this is how you'll get this time.